Okay, we're going to go through the 2018 end of year paper for Sec 1. So let's go through section B now. So question 1, provide the name and the symbol of the SI unit of the following base quantity. So I want the name, I want the symbol. So for time, the SI unit is second. The symbol is actually S. For mass, okay, most people are mistaken that it's gram, but actually it's kilogram. And hence the symbol is kg. Next, complete the following sentences. Show you're working clearly. This is 650 micrometer. I want to convert it to meter. So the step actually is to remove micro. So to remove, actually I need to multiply. Micro is 10 to the power minus 6. So if I were to take 650 multiply by 10 to the power minus 6, if you press your calculator correctly, you should get 0.00065 meters. Okay, next, 0.45 MA. What is MA? MA stands for mega ampere. Okay, is equal to how many ampere? So once again, I'm just purely removing capital M, which is mega. So I'm going to multiply by 10 to the power 6. So if you were to press your calculator, okay, 0.45 multiplied by 10 to the power 6, you're going to get 450,000 ampere. Right? So that's for question 2. Now for question 3, the equation below shows the relationship. State each of the following statement is correct or wrong. So now, based on the statement, you will know that the period, which is capital T, is only affected by the length, is only affected by the gravitational field strength. Anything other than the length and gravitational field strength actually doesn't affect the pendulum. Hence, the period of pendulum will increase when the gravitational field strength increases. Will it affect? Yes. But we look at the relationship here. When G increases, that's the gravitational field strength. This is G. Can you imagine a fraction? Okay, I actually don't care square root. I don't care square root too much. But in a fraction, if the denominator increases, what happens to the value? You realize the value will be smaller, right? Comparing 1 over 1 over 2 versus 1 over 4. You know that 1 over 2 is bigger than 1 over 4. So when the G increases, actually T will decrease. So therefore, A is false. Okay, because the period of pendulum will decrease when the gravitational field strength increases. Next, the period of a simple pendulum will decrease when the size of the pendulum will increase. Now the size here actually refers to the volume. Okay, the bigger the volume, the smaller the volume. Now because it's all about the volume, okay, so hence the key is, do you remember, period only is affected by the length or the gravitational field strength. Therefore, the period of a simple pendulum will decrease when the volume increases. Answer is false, because actually it doesn't affect or will remain constant or remain the same. Okay, so take note of that, question 3. Next. Okay, so next, what we're going to have here is state 2 differences between mass and weight. It's actually a whole list of answers that you can be giving. Okay, so let's show you the answer. Okay, so you realize that these are the possible answers. First one, mass is the amount of matter in a body, or weight is the gravitational field strength acting on an object. So this is the first possible answer. This is actually sort of like the definition. Next, mass is a scalar quantity while weight is a vector quantity. So this is the idea of a scalar. What is it? This is a quantity, physical quantity with magnitude only, whereas a vector has both magnitude and direction. Question 3, question 4 again, but then you're looking at the third thing that we can say is in terms of the SI units. So mass is kilogram, or weight is Newton. So do take note, make sure that you have both the name itself and the symbol. Okay. Next, mass is independent of gravitational field strength, whereas weight is dependent on gravitational field strength. So do take note that this is another reason, okay, another possible differences. Last one, mass is measured with a beam or electronic balance, or weight is measured only with a spring balance. So these 5 are the possible answers over here. Do take note, please always have the comparative term, okay, whenever you are stating differences. So realize the comparative term we're using here is the word while. You can actually use the word while. You can also use the word but. You can use the word however. So any one of these comparative term is alright. Okay, next let's go through question 5. So question 5 says the table below shows the details of a softball and a baseball. So what are the details here? They give you the mass. So softball 200 grams, baseball 150. They are explaining why is it harder for a person to catch a softball compared to a baseball. So first difference is you can observe immediately that a softball has a higher mass. Take note, the word is mass, not weight, not heavier, but higher mass than baseball. Okay, why we try not to accept heavier? Because are you comparing weight or are you comparing mass? It's very important for this question to really talk about the idea of mass. Now, why is mass so important? Because the higher mass would result in, okay, so have higher mass than baseball, hence a softball would have a higher inertia. Now the question is what exactly is inertia, right? So what is the impact of it? So whatever in the bracket is actually not included, is not really necessary in this answer. I'm just going to let you know that if it's a high inertia, means it's more reluctant to change its state of motion. So what it means that when you throw a softball, because a softball has a higher mass than a baseball, it's harder to stop. Stopping is about changing its motion. Okay, so therefore that's for answer for question 5. Next, question 6. Okay, this is the old format, so do take note, just do all the questions. Okay, so the diagram shows the vernier caliper when its jaws are closed, when it's measuring the width of 4 pencils. So first thing first, when you look at the vernier caliper over here, realize there's 0 error. So when they say the jaws are closed, and when the jaws are closed, actually they're telling you that, okay, maybe there's a 0 error, let's check. So because the 0 is not aligned, you know that there is a 0 error over here. So what is the 0 error? So first thing, take note, because the vernier 0 is to the left hand side of the main 0, therefore we know that it must be a negative 0 error. When I got negative 0 error, the main scale will be taken as 0.0 cm. The vernier scale, okay, I'll look for the line that matches, is over here. Now do take note, because there's a negative 0 error, I'll count backwards from 10. So I got 1, 2, 3, 4, 5, 6, 7. So my vernier scale reading is actually 0.07 cm. So therefore my negative 0 error is actually negative 0.07 cm. This is my 0 error. So state a type of 0 error indicated. This is actually a negative 0 error. Okay, determine the 0 error, indicate the sign of 0 error clearly. This is actually negative 0.07 cm. Now, next one, this is when I have the 4 pencils. So this is the measurement of the 4 pencils, okay, which includes 0 error still. So let's find main scale reading of 4.1, 4.2, 4.3, but it hasn't crossed 4.4 yet. Therefore, the main scale reading is 4.4 cm. In terms of the vernier scale, the line that matches is here. So because this is not a 0 error, neither is it a negative 0 error, okay? Because this is not negative 0 error, we're just going to count it as per normal. So this is 1, 2, 3, 4. So the vernier scale is 0.04 cm. Hence, we're going to get a 4.44 cm over here. Okay? Sorry, 4.34. Mistake, sorry. The main scale is 4.3, vernier scale is 0.04, so this is 4.34 cm. Now next, once I got the measurement of the 4 pencils, I got a negative 0 error. Okay, I can actually do part 3 and part 4. Determine the vernier caliper reading when it's used to measure the width of 4 pencils. So the vernier caliper reading is actually 4.34 cm. Now to calculate the width of one pencil. Let's find the actual width of 4 pencils first. So what I need to do is I must take the reading of 4 pencils minus the zero error. So I know the reading on 4 pencil is 4.34. The zero error is negative 0.07, so I'm minus 0.07. So what I'm going to get is 4.41 centimeters. And because I only want one pencil, therefore one pencil is equals to 4.41 divided by 4. So I've got 4.41 divided by 4. The final answer, okay, take note, always round off to 2 or 3 significant figure. I'm going to round off 3 significant figure over here. So I'm going to get 1.10 cm, 3 SF. Okay, so this is the answer for part 4. Now explain why the width of 4 pencils was measured to determine the width of 1 pencil. So the key idea here is, okay, why we do this is to find the average width of 1 pencil, okay, so that we have a greater accuracy. So really the key idea here is we are looking out for the average width of 1 pencil, and this will actually provide us with a greater accuracy. The one that most of you are very familiar with writing is sort of like take, okay, this one is the one that you always like to write, take multiple reading, then determine the average. Now, but what does it do? Okay, if you take multiple reading, then determine the average, okay, what does it really do? Okay, you actually have a greater accuracy because you reduce the error. So this is actually what's happening when you are doing this part over here. Okay, next. Okay, an alloy consists of 30% metal R, 70% metal S by mass. The total mass of the alloy is 750 gram. It is known that the density of R and S are 8.75 and 10.5 gram. Find the average density of the alloy. So one method that I always advocate to my students when doing part B is really to draw a nice little table with the mass, volume, and density. So I have a metal R. So I mean I draw it over here, metal R, metal S, and the alloy of R and S. So let's go down a bit more. Then after that, in terms of the 3 rows, I'm going to have the mass, I'm going to have the volume, I'm going to have the density. Okay, so now based on this, how to find the average density? Let's write down some of the stuff first. So I know the alloy consists of 30% metal R and metal S by S. So it tells me that the R is 30% of the total alloy mass, S is 70% of the total alloy mass, and I know based on the next part the total mass is 750 grams. Next, the density of metal R and S are 8.75, so R is 8.75 gram per cm cube. S is 10.5 gram per cm cube. That's all the details I have so far. So let's do this step by step. Okay, now, first thing, you see, I got a mass of the alloy. So the mass of the alloy actually is sort of like 100%. So if I know the mass of the alloy is 100% and is 750 gram, I can find 30%, I can find 70%. So let's find, so this one is 750 multiplied by 30 all over 100 to find 30%. So 750, okay, times 30 over 100. What you're going to get is 225 grams. Same thing for S. Okay, what you're going to do, you're going to take 750 multiplied by 70 over 100. So you're going to get 525 grams. Now, as a teacher, what should I do next? I got a mass, I got a density. So the triangle that you will actually always be using is M. D equals to M over V. Density is mass over volume. So this is a triangle you have over here. So to find the volume, we take the mass divided by density. So the volume of R is to take the mass divided by the density. Okay, you can find the volume. So I take 225 divided by 8.75. You're going to get 25.7 cm cubed. Same thing we're going to do over here. Let's find the volume of S. So I take 525 divided by 10.5. Okay, so we'll take 525 divided by 10.5. You're going to get 50 cm cubed. Now, when you mix R and S to get the alloy, you will also be able to find out that the mass of the volume of the alloy will be the sum of these two. And hence the volume of the alloy will just be 25.7 plus 50 will give you 75.7 cm cubed. Now, once I got the mass, I got the volume, I can find the density. So to find the density, I'll take the mass divided by volume. So it's 750 over 75.7. So what you're going to get if you press your calculator is actually 9.91 gram per cm cube. So this is the final answer for this question. Okay, so next one, let's go. This is the other part. So actually, the 2018 provide quite a good range of questions. We can try it out. So it shows a micrometer screw gauge being fully closed when it's measuring the width of a bundle of wires. So first thing, you can see here jaws are closed, so we're looking at the zero error. So you can see here, okay, in this case here, this is actually a positive zero error because the main zero, the datum line, this line over here actually is called the datum line. Okay, is actually above the thimble zero. So if this is going to be the case like this, okay, you'll know that this is a positive zero error. So what's the reading here? 6. What's the reading on the main scale? You realize 0 is the only one you see. And for the main scale reading, okay, the last seen value on the main scale is the main scale, this is the thimble scale. Huh? Main scale reading that you can last see is actually 0.0 mm. The thimble scale reading that you can last see, okay, or that matches the datum line is actually 0.06 mm. Hence, you add these two up, you're going to get 0.06 mm. Positive. So the type of zero error indicated, this is a positive zero error. What is the zero error over here? It's positive 0.06 mm. Next, calculate the corrected width of the wires. Okay, so I want the corrected width, not the reading over here only. So let's first find the reading of the wires with the zero error inside. So this is 5. This line over here actually is 5.5. 6, 7, this is 6.5. So the biggest reading you can see on the main scale is actually 7.0 mm. Next, the datum line over here actually matches the thimble scale value of 29. So the thimble scale will actually be 0.29 mm. Add these two up, you got 7.29 mm over here. So therefore the corrected width of the wire, the corrected width, okay, corrected width is actually take the reading and minus the zero error. So the reading is 7.29, the zero error is positive 0.06, hence you're going to get 7.23 mm. So this is the corrected reading. Okay, next, let's scroll down. An alloy consists of 25% metal X and 75% metal Y by volume. The mass of the metal X and Y forms the alloy 1,500 grams, 750 grams respectively. It's known that the density of the alloy is 12.5 grams per cm cube. Find the density of metal X. Okay, so let's start. B part 1. Okay, to do this, remember I told you, try to draw the table. So X, let's try to draw more to the left. X, Y, and the alloy. Okay. This is the mass, the volume, And then of course the last row is the density. Scroll down a bit more so I got more space. Okay, then never yourself 25% metal X, 75% by and 75% of metal Y by volume. So it is 25%, is 75%. Mass of a metal X and Y that form the alloy is 1,500 grams, 750 grams. Next, last one, the density of the alloy is 12.5 gram per cm cube. Okay, so these are all the info that's given to you. Where you're supposed to find is the density of metal X. Now, obviously, to find density, you need the volume of metal X. To find the volume of metal X, because of this 25-75%, you know that you need to find the volume of the alloy. Because you're given density, to find the volume of the alloy, okay, you need to actually find the mass of the alloy. So these are the 4 blanks that we need in order to complete to find the final answer. So let's start. Because you know the alloy, the mass of the alloy is the sum of these two. So let's start by finding the mass of the alloy itself. So 1,500 plus 750, what you're going to get is 2250 grams. Now, because you got the mass of the alloy, you can actually find the volume of the alloy. So once again, you use your triangle. To find the volume is mass divided by density. So 2250 divided by 12.5. What you're going to get is 180 cm cube. Because I know the volume of the alloy will be 100%, so 25% is actually X. So I'm going to take 180 multiplied by 25%. So 25 over 100. So what you're going to get is 45.0 cm cube. Hence, to find the density, you take the mass divided by the volume. Okay, and when you do this, you're going to get 33.3 gram per cm cube. So this is the answer for the density of X. Now, they say the density of liquid Z is 5.0 gram per cm cube. Explain metal X will float on the liquid. So you can see obviously here, first thing you can say, metal X is denser than liquid Y. I mean, this makes sense, right? 33 compared to 5. Okay, liquid Z. Because it is denser, hence metal X will sink in the liquid. Okay, which means that it will not flow. So this is how you're going to get your full 2 marks. So that's it. Okay.